Hi there, Algebra 1 kids. Today we're going to go through solving quadratics by factoring. So Miss Jensen in the first video showed you how to do factoring and reviewed all of those steps. So now we're going to talk about taking factoring and then solving. So what we're trying to find are the solutions, or they can also be called roots, zeros, or x-intercepts. We're trying to find the place where the parabola, the graph of the quadratic, crosses the x-axis. So we can do that by factoring, because that's why we've been doing it, is set those factors equal to 0, and then we can find those x-intercepts or solutions. Okay, so just going to go through the steps really quick, and then we'll go through a couple problems. So first step, we want to make sure that our quadratic equation is equal to 0. And then we want to factor the left side. Normally we put our quadratic on one side and our 0 on the other, so it doesn't matter if it's on the left or right, but for now we're just going to say on the left side. And then we set each factor equal to 0 and solve each factor for x. So in this given equation, we would take it and we would set it equal to 0, and then we would try to find factors of -10 that add to give us 3, set those factors equal to 0. But I have some examples ready for you, so that's what we're going to take a look at next. Okay, so we've got a couple equations here that are not in standard form. So normally when we factor, we're used to seeing things in standard form, meaning ax squared plus bx plus c. So we're going to start with this example here, number 17. You can see it's not set equal to 0, so the first thing we're going to do is subtract 21 from both sides. Okay, that's the easiest move that we can do to get everything on one side. And the other thing that's helpful to think about is looking at the x squared terms. I like to keep my x squared terms positive. And so we'll get more into what if we see it on both sides here in a minute. But we want to keep the a value positive if we can, because then we don't have to worry about negatives in that case. Okay, so if I move that 21 to both sides, or subtract 21 from both sides so that I move it to the left side, I now have x squared plus 4x minus 21 equals 0. So in my classes, we like to talk about identifying our ABC values. So our A value is a 1, our B value is 4, and then our C value is -21. And we take our A times C value and we put that in the top of our x. In this case, it's going to be -21 because A is 1. Okay, and then our B value is 4. So we talk about a shortcut in my classes of if A is 1, then we can just find factors of C that add to give us B, and then we don't have to make our box. So we want to start thinking of the factors of -21 that are going to add to give us 4. So right now I'm thinking that 7 and 3 might be good possibilities. So I'm going to put in a 7 and a 3. But now we need to decide if it's going to be positive or negative, because we know when we multiply, if I take a positive times a negative, I should get a negative. So one of these is going to have to be negative, and I want to think about which one's going to give me a 4 when I add them together. So in order to make that happen, I need to do -3. Sorry, I'm really slow with writing on this because I'm writing with a finger pad and it's tough. Okay, so then we put those values inside our parentheses. The reason we can do this is because A is 1. It's a shortcut. We used to make the box all the time, and then we said, okay, if A is 1, then it actually keeps showing up that it's just those numbers. So we put them in our factors. So my first factor is x plus 7. The next factor is x minus 3. Okay, so then our next step is to set each one of those factors equal to 0 and solve for x. So if I have x plus 7 equals 0, then what I would do is subtract 7 from both sides, and my first answer would be x equals -7. My other factor is x minus 3 equals 0. So what I would do here is I would add 3 to both sides. I know this is really slow, sorry about that. Okay, so my second answer, or my second solution, would be +3. So my answer for this, I would say, is x equals -7 or +3. Okay, for the next few questions that are here, I just want to talk through making sure we're getting everything to one side. So like it says here, move, factor, and solve. Okay, so we want to get that. We want to look at both sides. I see a positive x squared on this side, so that's good. So what I would do is just move that 4x to the other side and have x squared minus 4x minus 45 equals 0. And then we go through a similar process as 17. Okay, for number 19, I see x squared as positive on the left side. So again, I'm going to move this 7x to the other side. So I'd subtract 7x from both sides. This time I do have an x on this side, so I have to be careful to take negative 5x minus 7 more. So I would have x squared minus 12x minus 64 equals 0. For number 20, same sort of thing. I want to subtract the 4x and the 1 on each side and make sure I'm lining them up with my like terms. So over here I would now have x squared minus 14x and then plus 48 equals 0. Okay, but I want to get into factoring and solving a few more types of problems. Okay, so 21. This one's a little bit tricky if we're looking at both sides to start. I have 11x squared and I have 1x squared here. So when I'm taking a look, this side is the side that has the positive x squared, and so does this side, but this has the greater, more positive. So I would want to make sure that I subtract the x squared on both sides, which means I'm going to subtract 8x on both sides as well. I forgot to put that step in there. So now I'm going to have 11x squared minus x squared, which gives me 10x squared. And I'm going to have minus 8x equals 0 because on this side, both of these terms cancel out to give me 0 on that side. Okay, so then I'm looking at how I can factor and going through the steps that Ms. Jensen provided on the other video. The first thing I want to look for is a GCF. So I see that both terms have an x, so that's something I pulled out right away. And then the other thing we want to take a look at is the numbers. So I've got 10 and I've got 8. I know both of those can be divided by 2, but we want to think, can it be anything greater than that? I don't think it can be. So we're going to take out a 2x, and that's going to leave me with 5x here and minus 4. So now my two factors are 2x set equal to 0, which means I'm going to divide both sides by 2. So my first answer is going to be 0. Then I need to make sure I set my second factor equal to 0 as well. So my second factor is 5x minus 4. So this one's going to kind of have two parts I'm going to have to solve. First thing I'm going to do is add 4 to both sides. Sorry, I know this is slow. Okay, and so then we will have 5x equals 4. My next step then would be to divide by 5 on both sides. Okay, so we're going to divide by 5 and divide by 5. To make that happen, 5s will cancel out, and my other solution would be 4/5. I like to keep answers in fraction form. All right, 22. Again, I want to go through and make sure we're understanding. We're going to move everything to the greater, more positive x squared side. This time we just have x squared on one side, so we're going to subtract 9 from both sides. 16x squared minus 9 equals 0. So here we want to think about all of our opportunities to factor. Factoring, we go through, and if there's a GCF, we take it out. In this case, there's not a GCF, and we can go through and identify our ABCs. But this is a special case. So if we can recognize that it is, then we can use a shortcut. So special case here, 16x squared is a perfect square, and so is 9. So with my kids, we talk about then if those are both perfect squares, I'm going to take the square root of 16x squared, and I'm going to take the square root of 9. The square root of 16x squared would be a 4x. So we're going to put that as our first term in each of the factors. And then if I take the square root of 9, it's 3. And since I don't have a bx term, we know that if one sign is positive and one sign is negative, if we were to multiply this all back out, that middle term would cancel out because I'd have 4x times a negative 3 and a 4x times a positive 3, which makes that term cancel. Okay? Okay, so then we're going to set each of those factors equal to 0 and solve for x. So I have 4x plus 3, 4x minus 3, and what my steps would be here would add 3 for the blue one, add 3, and then divide by 4. So this would be 3/4 for one of my solutions. Okay, for the one in green, first step would be subtract 3, then divide by 4. So I'd have negative 3/4. That looks like a 1, sorry about that. So x would be negative 3/4 and positive 3/4. Okay, now I want to switch gears and make sure that you see some other ones that are factoring with a not equal to 1. So I just want to go through an example, just talk through one or two with you real quick. I will leave these other examples kind of up here, but example 1, okay? 3x squared plus 9x minus 12. Identify ABCs, but wait, first I can take out a GCF, so we do that and then we factor just like we did previously. Example 2, same sort of thing. I can factor out a GCF. That makes it a little bit easier when I am identifying my ABCs, so that A is only 1. It makes it easier when we factor. And then the key here is, though, if you have a GCF out in front, like 3, if I divide both sides by 3 in example 1 here, 0 divided by 3 is still 0. Okay, so then what's kind of cool is then we can just take each of those factors, set them equal to 0, and I can find my solutions. Same with over here. We divide by 5 and it kind of just cancels and this still stays 0. So then we can set each of those factors equal to 0 and solve for x. Okay, if we move down a little bit, example 3, here we do not have a GCF. So we identify our ABC values. We take A times C and then we find B. So we're trying to find factors of negative 10 that add to give us 3. Those would be 5 and negative 2. Okay, so in the box, we always put our x squared term on the top left and our constant term on the bottom right. So we're going to do 2x squared, and then I put this 5x in, negative 2x minus 5, and then I always say factor up and left and take the sign of the box you're factoring towards. So when we factor up, we can take out a 2x. When I factor up here, I can take out a 5, and it needs to be positive. When I factor left, I take out an x, and then here I would take out a negative 1. So my first factor is x minus 1, the second factor is 2x plus 5, and again we set each of those factors equal to 0, solve for x, I get 1 and negative 5/2. Last example I just want to talk through real quick. Again, make sure first that everything is equal to 0. You might have to move things around first, so make sure you do that. But here I don't have a GCF that I can take and divide each of my 3 terms by, so identify my ABCs. I have 8, negative 22, and 5. I want to find factors of A times C, which is 40, that add to give me negative 22. What works is negative 2 and negative 20, so I put those in my box. I have my 8x squared and 5, and then we factor up and left, okay? Take the sign of the box you're factoring towards. So that should be 4x minus 1 and 2x minus 5. Set each of those factors equal to 0 and solve for x. So here I'm going to take and add 1 to both sides and then divide by 4. Here I'm going to add 5 to both sides and then divide by 2. So my answer should be 1/4 and 5/2. Sorry that was long. Thanks for listening. Hope that helped if you needed a little bit of factoring and solving review.